Heron's formula is a formula to calculate the area of an oblique triangle. We derive it from the law of cosines, but it goes like this. Here's the formula. The area equals, well, all this business here. S times S minus A times S minus B times S minus C. But what is S? Well, S in this formula is something we call the semi-perimeter. So we add up all three sides of the triangle and then we divide by 2. So let's suppose I have a triangle, I don't know, that looks something like this. So it's an oblique triangle. Let's call this 3 centimeters or whatever. And let's call this, say, 7, and we'll call this one 9. So we'll say we're dealing in centimeters, just so we have a unit at the end. So we want to know what is the area of this triangle. So the first thing we do is we calculate what's called the semi-perimeter. So we add up the three sides, 3 and 7 and 9, and then divide by 2. So that equals 19 divided by 2, or 9.5. I need to scooch this just a smidge. So, going up to the area formula, we'd say, all right, we have area is the square root of S, which is 9.5, times S minus A, and it doesn't matter which side is A. Say this one is A. So 9.5, put a decimal there, minus 3 times 9.5 minus 7. We'll say this one is B. And then we'll say this guy must be C. So 9.5 minus 9. Oh. So we will go ahead, type this into the calculator, and we'd get, well, we'll do it step by step here. 9.5, 9.5 minus 3 is 6.5, 9.5 minus 7 is 2.5, and 9.5 minus 9 is 0.5. And then at the end, when we multiply all this stuff together, we have to remember to take the square root. So I'm going to go ahead in my calculator and multiply 9.5 times 6.5 times 2.5 times 0.5. So I'm coming up with a product of 77.1875. Double check me on your calculator. Make sure I did not make a mistake. If I did, let me know in the comments down below. So I'm going to take the square root of this, and that gives me an area of approximately 8.8 square units. And we said we were going with centimeters, so that would be 8 square centimeters for this triangle right here. So that would be the final answer. So that's kind of a cool thing, that you can figure out the area of an oblique triangle just by knowing its side lengths. So let's look at one more example. So you may see these in the form of a multi-step problem. So here are two sides and an included angle of an oblique triangle. So we have 13 and 9. We want to find the missing side down here of the triangle and then find the triangle's area. So we have to do two problems. We have SAS, which means I'm going to have to do the law of cosines. So if this is C, this is A, say this is B, that makes this A, B, and C. So we would say that C squared equals A squared plus B squared minus 2AB times the cosine of c. So c squared is going to be a squared, which is 13 squared, plus b squared, which is 9 squared, minus 2 times a times b times the cosine of 130 degrees. So I'm going to take a moment and just type all of that into my calculator. 13 squared plus 9 squared minus 2 times 13 times 9 times the cosine of 130 degrees. So I'm coming up with a c squared of, well, 400.4 roughly. So what I'm going to do is take the square root of my answer, and I find out that c is about, put my about sign, is about, well, 20.0. So we'll go with 20, just to make our calculations a little easier. So that's the first step. So sometimes you have to take a first step and follow it up with a second step. So my second step is then going to be calculate the semi-perimeter. So I've got, well, let's see, 13 plus 9 plus 20 now. And I'm going to divide that by 2. So that equals, let's see, I'm going to add this to my head. Check me in the 10, 20, 30, 42. So that would give me a 42 divided by 2. Check me on your own calculator. Let me know in the comments down below, but I'm pretty sure I did that okay. So next, step number 2, we're going to find the area. So the area formula again is S times S minus A times S minus B times S minus C. Now a lot of students will ask, does it really matter if I use A, B, C, or if I'm just multiplying this all together? It doesn't matter which order we multiply these factors in. We're going to get the same product. So in any event, I'll try to stay as close as possible to what I called what. So A was 13. So S minus A times S minus B times S minus, well, let me go ahead and put some values in. That would be helpful, wouldn't it? So S is 21 minus B times 21 minus C, which we just figured out was 20. So go ahead, we'll type this into our calculator. Well, first let's simplify it out. I've got 21 times 21 minus 13, that would be 8. 21 minus 9, that would be, let's see, 10, 12. And 21 minus 20. So that would be, let me scooch this back, that would be a 1. So we're going to go ahead, type this into the calculator, and we end up with 21 times 8 times 12 times 1. 21, I typed in 1, times 8 times 12 times 1. So I end up with the square root of 2016. So that is not a perfect square. So I'm going to take the square root of that anyway, and going to round to 1 decimal, and I find out this is about 44.9. So we didn't set up a units here, so this would just be square units, whatever they were, square miles, square inches, so on. So there is a problem where you may have to first figure out a missing side, then go ahead and apply Heron's formula to the problem. we'll look at one last example. So here's where an application-based thing may come into play. Let's suppose we're looking at a triangular shaped plot of land right here. And we know that we measured one side, and we know it's 6.8 miles and 5.8 miles on another side and 4.9 miles on another side. So if I wanted to know the area of this, suppose because I'm being charged per square mile of land or something, I would like to know how many square miles are in here. So I would take the three measurements, 4.9, 6.8, and 8.4, and divide by 2. So that's called figuring out the semi-perimeter of the triangle. So we add those all up and we get 4.9 plus 6.8 plus 8.4 is 20.1. 20.1, let me turn my pen back on here, divided by 2. So that gives me a semi-perimeter of 10.05. So after that, go ahead and substitute into your formula. So semi-perimeter times the semi-perimeter, let me fix that, semi-perimeter minus one side times the semi-perimeter minus another side times the semi-perimeter minus that third side. So, make my little thing go over. So go ahead and use your calculator. So according to my calculator, I come up with square root of, let me go here real quick. I made one mistake. 277 point, it's a long-ish decimal. Not long, but 277.5495938. So I don't have to copy down that whole thing because it's in my calculator. But what I want to do is take the square root of that, and then I find out, hey, look at this. I have about 16 point, if I round to the nearest tenth of a square mile, 16.7 square miles. So now we know how many square miles this plot of land is, and we make sure we don't overpay for it. So there you go. That's a third example with an application.